Hello, welcome everyone. My name is Ruth Slavid. I am chairing this event for the day. As you've just seen, this first in a series of 4 webinars, we'll be looking at the very important question of how are we going to deliver net zero housing? It's an enormous challenge, obviously. We're talking about we have this target to get to net zero by 2050. We've seen the changes to Part L, the introduction of the Future Home Standard. It's absolutely the right aspiration. I'm sure no one would disagree with that, but it is an enormous challenge. And we have 5 fantastic speakers today who are going to give you their ideas of how we can get to that. And after they've all spoken, we will have a panel discussion. So please, you've got a question function on your screen. Do send in questions. And my advice is to send them in when they occur to you, because otherwise sometimes you forget, and we should have a lively discussion at the end. So I think there's nothing more for me to do than just to introduce you to the first of our 5 speakers, who is Martin Townsend, who is the director at BSI for the Centre of Excellence for Sustainability. Over to you, Martin.
Brilliant. Thank you, Ruth, and thank you for that introduction. And welcome, everybody. I'm never too sure, actually, if it's worthwhile going first or going last, because I know there's so much to cover, as Ruth said already, in terms of this conversation. But having spoken to all the other speakers this week, I feel very confident that anything I miss, they will easily capture in terms of their own ideas and sharing. As Ruth said, we've got lots of ideas to share with you, lots of thoughts and lots of experience to share with you. But actually, it's made so much richer if you contribute. So I'm looking forward to the end of the session when we answer your questions as well. So I have no slides. So I will just be talking to you from my heart and my head and my experience. And to make sure I kind of take you on this journey to answer this question in terms of how do we achieve net zero housing, I need to get to you some structure. So I want to talk about mindset. What's the mindset that we need to approach this conversation? What's the scale of intervention? How do we think about this in terms of the component that goes into a building, to the product, all the way up to the city scale? How do we think about that? We need to talk about the elephant in the room, and just before you joined us, Rob and I were having a fairly good debate about new versus old. So I think we need to kind of actually put that on the table as well in terms of making sure that we share some of that information. And then importantly, I suppose, we need to talk about the future in terms of government reviews, etc., and things that might shape or drive this even quicker. So let me start off then. I work at BSI at the moment, but in my career, I have been very, very fortunate to work with some very inspiring individuals. And I remember a time when I was working at BRE and talking to Bill Dunster. Some of you might know Bill Dunster. He reminded me that back in about 1997, he, along with Peabody Trust, Bioregional and Arup, built BedZ, or designed BedZ back in 1997. Finally, I think, commissioned it in about 2002. And the point that he was making when I asked him, why are we not driving low carbon housing, net zero housing as quickly as we need to? The comment he made to me, it's all about the mindset. It's not about seeing this as a barrier or even something that we should be thinking about. It's about making sure that we do this and we actually use all of our skills and all of our knowledge. All of you today will be joining us to kind of hear some of that experience. You will have been to university, you would have worked with your other professional colleagues. So you have the knowledge. In many respects, is about the way you tackle this issue in terms of how you want to break down the barriers to achieve net zero housing. So the mindset's important. It isn't just about engineers and architects. It is also about policymakers as well. And it's really good to see when you start to look at the London plan, the policies that are now coming into play to drive that change as well. It'd be very easy, I suppose, for you to say back to me that, okay, so you can look at this from large developments and large city perspective, but this morning I was looking at the web and looking at the various different developments that are taking place across the UK and across Europe that are already net zero, and also where local authorities, small local authorities in rural areas, are setting policies and setting standards and sharing best practice and sharing guidance documents to achieve this. So we have that knowledge, we have that experience. It's about making sure that we really use all of that to best advantage. When it comes to mindset as well, I think it's important to appreciate that the mindset of the homeowner, the consumer, is also changing. They are now more aware than they have been before in terms of the environments in which they live, and also when it comes to the cost of living crisis, the relationship here between the energy they're consuming and the cost of it, and making sure that we are changing behaviours as well as actually changing the built environment in which we all depend. And I think that relationship is something which will become more important in future years, in terms of as consumers becoming more involved, as data becomes more available, as we start to see services really driving our domestic stock. The next kind of point I wanted to share really is about scale. When we talk about housing, we think immediately of the house. What we need to think about when we think about net zero is what's the right scale of intervention to get this right. Is it the component level? Is it the product level? Is it the building? Is it the site? Is it the neighborhood, the community, or the city? And actually, the other thing to share with you is each one of those scales of intervention brings a different cost envelope and a different advantage. I'm doing some work at the moment in terms of a new development that's taking place in London, and they're starting to understand the relationship between the individual building and that community, that larger scale, and the relationship between the domestic stock and the commercial stock. How can we actually use heat from data centers and bring that into domestic buildings to make sure that we share that heat and actually think about that in a more efficient way? So the scale of intervention becomes important. In that same breath, I suppose, we also need to think about different business models. So when we start to think about the products that we put into our houses to actually provide us with heat and light, etc., do we now start to think about them as a service model? So should heat become a service, and you don't need to worry about how that is delivered into your house? Is it a gas boiler? I don't need to worry, it's delivered to me as a service. So are we starting to see a change in business models in terms of how we start to think about how we receive some of these things that go into our buildings? And I think that becomes an interesting talking point, if nothing else. The next kind of thing I really want to kind of just put on the table a little bit is this issue about new versus old. Now, it's got many layers to it. The first, I suppose, to share is that the biggest mountain to climb by far is our existing stock. So when we start to look at the changing regulations, looking at new build, it is slowly changing. It's importantly kind of pointing us in the right direction. When we start to look at the impact our existing stock has, it is by far the biggest challenge in terms of how do we retrofit, how do we think about what we need to do. And actually in that, we need to think about the embedded carbon as well as the operational carbon. As we've invested so much in our existing stock, how do we effectively drive the change in terms of making sure that we're making the right decisions? There have been endless initiatives in terms of trying to think about how we retrofit our existing stock. And if we're not sympathetic to the age of buildings and how they've been constructed, and we're working with how they are best improved, then we will actually present different problems in terms of actually trying to solve that issue. And I think that becomes important, that we need to make sure that when we talk about a low carbon housing sector, we are looking at it from both a new and existing perspective. And we're making sure we're making the right decisions in terms of how that works. Equally, there are lots of lessons that we need to learn from our existing stock as we start to change regulations for our new build. So how do we make sure our buildings don't overheat? I live in a Edwardian house, and actually over the years I've upgraded it so it's now energy efficient. But actually in the summer months and the summer that we've had, it was cool because of the way it's been constructed, in the way it operates. We need to make sure that we're thinking about the right level of insulation, but also the changing environment that we're going to have into the future if all the predictions are correct. Equally, we need to think about adaptation, and that's adaptation for us as society. We are an aging, growing population. What are our needs in terms of how we may design our buildings, so that if we're making sure that the fabric efficiency of the building is sound, that if we're changing the fabric of the building, then in essence, we need to make sure we don't actually damage the efficiency it provides. So that kind of issue in terms of new versus old, I think, becomes important. Mindful of time, I'm going to just kind of finish on the point about the future. So one of the first thing this new government did was to start to commission a review. So Chris Skidmore is now being asked to look at a review in terms of the net zero targets. So since it was published, the net zero strategy published over a year ago, we have seen a massive amount of change in terms of energy, in terms of the issues around Ukraine, etc., etc. It's going to be really interesting for us if the government is committed to actually achieving net zero, what Chris Skidmore is going to find in terms of how it's going to affect us as individuals, how it's going to affect us as a society. Equally, I think it's going to be interesting to see what happens as we start to see further changes in terms of European legislation, and what does that mean in terms of supporting and actually making the right decisions when it comes to growth. So this growth agenda, how do we make that growth sustainable? How do we achieve our net zero targets in a way that actually supports everybody in society and make sure we build the best possible housing? So that's enough for me.
Thank you very much, Martin. I think it's really good to have that kind of overview where, I don't know about anyone else, but it made me think, yes, it's difficult, but maybe we can actually do it. We're going on to our next speaker now, who is Ben Cheetham, who is Senior Technical Innovation Coordinator at Barratt Development. So we're hearing from a house builder now. Ben.
Thank you, Ruth, and good morning, everyone. And big thanks to Keystone for putting on these webinars. It's great to be here talking today. So what I thought I'd do with my time is really take you on a bit of a house builder's journey and drill down into some of the practical products and systems we're going to actually implement over the coming years to deliver zero carbon homes. I've only got 12 minutes or so naturally I'm going to keep things fairly high level, but more than happy to answer questions at the end. So if I start by looking at a bit of a roadmap into where we are now and where we're heading in the direction of travel. So 2019-2020, we saw consultations in building regulations around Part L, energy efficiency, but also ventilation in Part F, and a new regulation overheating, which Martin has just touched on there a little bit. That really kicked off an R&D project within Barratt's. And we went away and built the Z House, which is a zero carbon house, and I'll talk to you about that in the second part of the presentation. Those regulations have now been implemented over the summer, and so the headline figure really, all new homes built under those standards will need to deliver a minimum of 31% reduction in carbon emissions compared to previous standards. And then looking ahead to the future home standard, we're expecting that to be implemented 2025. That's really the hard cut-off for no gas. However, we're going to have a phased sort of approach leading up to that, which I'll come on to. And homes built to that standard will be around 75 to 80% carbon reduction. And it's worth noting the additional 20% will come through the decarbonisation of the grid over a period of time. And then a couple of commitments that Barratt's have made. 2030 is when we've committed to be zero carbon homes through regulated energy. And then as a business, through all of our direct operations, all of the energies that we use for our sites and offices and plant and machinery to actually build the houses, will be a net zero business by 2040. So just looking at what a home under new regulation, how might we deliver 31% carbon reduction? This isn't necessarily our defined specification, but a couple of examples of different products that we're going to start to see. So I suppose the first step is really fabric first. Principles is certainly a priority, remains a priority within our business. What that really means is, increasing cavity sizes, putting even more insulation in the cavity walls, also under the floor slabs, in the roofs, and really putting a nice warm jacket, an even warmer jacket around the house. So in turn, that really does emphasize the thermal bridges. So we have to assess, make sure we're looking at and addressing the key junctions within the external envelope. So once we've limited the heat loss through fabric principles, we look to what technology can we implement to reduce the overall energy demand. So things like PV panels are going to become more standardized now on every house type, generating renewable electricity, but also we need to think about how we can recover some of that energy. So products and technologies such as wastewater heat recovery or flue gas that can recover heat that would normally be lost and then reuse it, helps drive down that demand from the house. Another key change is flow temperatures. So typically gas boilers you design at around 70 to 80 degrees, which is fairly typical. New houses will be limited and capped at 55 degrees. And in turn, we need larger surface area for our radiators. So radiators will increase typically 30 to 50% larger. We'll need to increase pipe work as well. And then also, do we implement mechanical ventilation? So not only to manage indoor air quality, continuously running extract fans in wet rooms and things like that, but also to mitigate risk of overheating. So yeah, this was a couple of ideas. You'll notice a gas boiler there as well. And as I've mentioned it, we're looking to have a sort of phased approach to introducing air source heat pumps. We know that air source heat pumps are going to play a key role in decarbonising our housing stock, both new build and retrofit. They're not necessarily going to be the only solution. We're doing lots of work around heat networks, and there's other low carbon options as well that are being reviewed and looked at. But we're actively using heat pumps today. We've got customers living in properties with heat pumps, and I suppose a few of the challenges really to deliver them at scale are really supply chain concerns and installers. There isn't enough accredited installers today to really deliver these at scale. So we're currently working collaboratively with the air source heat pump manufacturers, with government, with Heat Pump Association and people like that, and crucially our own contractors. We're really encouraging our own plumbing and heating contractors that they need to get upskilled and go away and get heat pump training and prepare themselves. So I won't go through all of this in the interest of time, but just the knock-on effect of the new technology. We're adding more complexity into the home, so it has a knock-on effect across various departments and areas. So I'll just pick a few of these out, but putting PV on every single house type now, that means less hipped roofs, more gabled roofs, because pretty much the whole roofs need that PV allocation on there. Customer education, we touched on this a bit in Martin's presentation, but it's going to be crucial. We can deliver really energy efficient zero carbon houses, but we need customers to adapt their behavior and ensure they understand how to operate their homes efficiently. And then skills and capacity, obviously we're adding new technology. We've mentioned heat pumps, PV panels. As an industry, we look to the target is 300,000 houses. If we're all going after those particular products, it puts even more pressure on an already strained supply chain and the installer base as well. So just a couple of challenges and barriers that we're currently working through and addressing. And then when we look to how we can deliver a 75% carbon reduction from the Future Home Standard, it's really everything I've just said: heat pumps or other sources of low carbon heating, but also things like battery storage. Do we start adding batteries in so the home can become smart about how it manages energy? So actually storing energy, selling it back to the grid when it's more preferential rates, or using it when it needs to, and looking at smart systems to actually manage all the different technology within the house. And then emitters is really important as well. So typically today radiators, but we're looking more and more at underfloor heating, especially when we're using it in conjunction with a heat pump due to efficiencies. So we're doing work around that at the moment. And then again, some of the key challenges around delivering the Future Home Standard today. Again, skills is a real challenge that I've touched on. if we just pick PV out again, there's, our allocation for PV is probably in the region of 90 to 100,000 panels a year, times that by the other, the industry. It's a lot of PV panels. It's a lot of installers that we need to gear up and get ready. Supply capacity, we have seen obviously some serious challenges in the supply chain over the last 12 months. So that remains a concern as we move forward. Overheating, as we're making our buildings more thermally efficient and with obviously a warming climate, we need to be mindful of overheating. Do we need to start looking at more north-facing elevations, reducing window sizes, or even looking at cooling later down the line at some point as well, be something we need to think about. And then grid capacity, we're obviously electrifying our homes, heat pumps, EVs, everything will be electric. What impact does that have on the grid? Is the grid, does it have capacity? And it's legitimate questions around that, as well as EV chargers as well, I should add in. So, and then the snake diagram in the middle here is really just to highlight the challenge with heat pumps that we're actively working through. If you're a plumbing and heating contractor today, it's still quite a lengthy process to become heat pump accredited. It can take several years, and there's quite a lot of paperwork involved. So we're actively trying to encourage, how can we slimline that? How can we incentivize our current gas engineers to go away, upskill themselves, and want to do it? And also just a bit on customer education. We're doing lots of research around our customers. There's still a lack of awareness around heating systems, although I would say certainly in the last couple of years, we've seen the shocks to the energy market. More and more of our customers are asking about how much does this house cost to run? What is the heating system? Which is certainly, it never used to be. And then the second part of my presentation, I just wanted to talk around our Z House. So this is a concept house that we built in conjunction with Salford University. It's a zero carbon house, and we want to go way beyond the future home standard. So it delivers around 125% carbon reduction. So it goes beyond the future home standards. And the idea behind this is we wanted to build not only a zero carbon house, but we wanted to challenge the supply chain in what technologies are available, and in order for us to really scale up and be commercially viable for a national developer to deliver at scale. And we had a number of drivers. We wanted to look at not only regulated and unregulated energy, we also want to look at embodied carbon. Embodied carbon is really important, and I'm sure others may pick up on this later. So we looked at how we can reduce the embodied carbon within the property. We also looked at reducing waste. We looked at how we reduce water. Obviously, water is scarce in certain areas. So we tried to address, and also nature, biodiversity, how do we improve that? So there are lots of different areas that we addressed in this sort of concept house. So we used a combination of MMC systems. So I'm just going to run through a couple of these here. So you'll see, for example, the roof was actually built on the ground with the PV panels and the tiles pre-installed, and that was craned into position. You'll see here the external brick, they were full brick panels, full elevations that were craned into position. So we actually didn't have a bricklayer on the site. And also the first floor, you'll see here more cladded systems with the windows pre-fitted, and it was a closed panel timber frame system as well. So on this site, we actually didn't have a tiler, we didn't have a bricklayer, and we did one elevation without any scaffolds as well. So we're thinking about the future as we need to grow our housing. There is an underlying demand. We need to think about different options about how we can not remove the reliance on the, for example, bricklayers. They're going to be a key part of moving forward, but to grow further, we need to look at more MMC systems as well. And then low carbon heating. We used a Mitsubishi Yokodan heat pump. Several years ago with heat pumps, there's a lot of concerns around noises and how they operate. Today, everyone's been very sort of pleasantly surprised how absolutely quiet these things are. Very quiet, work really well, provide a nice comfort levels in the house. So air source heat pumps with a hot water cylinder. We also put two batteries in there, two 10 kilowatt batteries, and there was over 25 PV panels on the roof. So all of this technology, really, what it means in practical terms is 4 or 5 days out of the week, it's actually generating enough electricity to support itself without actually drawing from the grid. So bills on this house were really cheap. I think they were about 30 quid a month. with about 25% of that being a standing charge. And then, we put various emitters in, much to the headache of our contractors. So we put underfloor heating in, and we put radiators. We also put innovative solutions like this thermal, it's called ThermSkirt. It's a heater skirting board, so hot water pipes running through the skirting board. And we also looked at electric solutions, so infrared heating panels. So the whole idea around this is we want to test. We have people moving in, and we can independently switch off the different emitters and find out what works for the how are the occupants engaging with it, what are the preferences, and which will help shape our decisions as we move forward. And then just a slide on smart tech. So we had lots of smart tech in there around managing the different technologies and voice activated lights and things like that. We also had low flow thermostatic showers, and so just conscious of the time. So just looking ahead to the next step. So that was a zero carbon house we built at Salford, actually on the campus. Our next project actually to further research zero carbon technologies and how we're actually going to scale up is called the Energy House 2. So this is a £16 million research facility at Salford. So it's essentially a large energy chamber, and they can actually control the weather. So, in terms of wind, snow, rain, and they can make it -20, +40. So really we're building a house within this chamber. It's currently under construction at the moment. And we can obviously drop those temperatures. We can test efficiencies of, for example, heat pumps and other technologies. And we can learn lessons that we need to take forward as we deliver zero carbon. So here's just an image of where we're at. So I think that data, that hard data that we're going to get from these projects is going to be crucial as well. So I think really just to sum up as well, that's what we've demonstrated. Zero carbon regulated energy is achievable. We know what we need to do. There's some barriers in terms of installers. We need to get them ready. We need to get the supply chain geared up, and it'll be a transition. We also need to collaborate with our supply chain. 60% of our emissions come from our supply chain in terms of embodied carbon in the products that we use. And a lot of our suppliers are smaller than us. So it's really important that we collaborate and bring them on the journey as well to drive that carbon down. So on that note, I think I'm probably over time, Ruth. So I'll hand back over to you.
Well, you've packed an amazing amount in there. It was fascinating to hear that. And I think both to see your sort of more theoretical projects and actually to see the work you're doing at the moment with commercial homes, where you are obviously having to balance all sorts of things, including the demands of the market. So having heard from you as a house builder, we are now going to go on to an architect, and we are going to hear from Robin Dreyer, who is director at CDC Studio. But before Robin starts, I would just remind everybody, with all this food for thought, please do send in your questions so that we can have as rich and as lively a discussion at the end as possible. And now I'll pass you over to Robin, who is muted.
I pressed M and it didn't work. Anyway, it is. I'm now unmuted. Hopefully you can now hear me. Yeah, good morning. Thank you very much for inviting me to talk to you. You've heard some very interesting speakers so far, so hopefully you'll find what I have to say equally interesting. And I'm coming at it really from the perspective of an architect, and I have 27 slides, so I'm going to whittle through those quite quickly. And I think really the first question is, the UK has set its target for 2050, and it's understanding how we get there. I suppose similar to the previous speaker, we've got there's two sort of elements to this sort of presentation. The first one really starts looking at sort of I suppose our understanding of where we are and what that what the market looks like from an architect's viewpoint, and then secondly some of the challenges we have in understanding sort of net zero. So 2050 seems a long way off, and I appreciate we're not going to necessarily get to 2050 and net zero. The target is to achieve that before 2050. But I thought it was quite useful just to start by seeing, 27 years in the future is 2050. But if you look back where we've come from 27 years, 27 years ago, houses broadly, and this came from the NHBC, document, we were putting insulation in walls and roofs and limited amount, if any, in the ground. But the houses themselves were very much, I suppose, similar to what we're looking at today. There were brick cavity constructions, double glazing, and we have moved, and I think we are moving, and there are some really good examples, but I don't really think it's moved perhaps as far as it perhaps ought to. And if you look at where we're going to be in 2050, I'm not really sort of necessarily putting forward this is where we are going to be heading. I don't think anybody really knows, but I think what we can probably say is that the houses are going to be probably taller. We're going to be more densely developed as space becomes more valuable. We're going to be dealing with overheating. I think we're going to, the world is going to be getting warmer, and we're going to be dealing with that, and that's going to be essential. We just experienced quite a warm summer. How do we overcome that? And this is a high-rise building with trees. The trees and the planting is creating shading, but it's part of an environment, and it's trying to create well-being and how people live. And I think nature will also kind of come into that. But I think really, I don't think any of us really know exactly where we're going to be heading. Where we are at the moment, though, is I think a different sort of picture. I live in Cambridge, and when you look at some key developments in and around Cambridge, it is I think probably best a mixed bag. I think there's probably an awful lot of gas still being used. I'm not sure there's a lot of photovoltaics on a lot of those developments, and I think a lot of those buildings are being built to the current regulations, and I think a lot of those are not. For whatever reason, these homes are not being built looking to the future. And I think we'll pick on this later on, but if you can imagine that some of these homes are being designed now and some are being built now, within 10 years, you could be having to replace your gas boiler with an air source heat pump, and that's going to come with a whole range of complications, and it's not going to be straightforward. And then you are going to be retrofitting it. And if you've bought a house 10 years down the line, actually to start retrofitting things like that, you could feel it's something you didn't expect. These are just two extracts, and I just want to kind of, this is just me just sort of offering you a mirror on what we sort of see and how we sort of what is out there. So these are not from any these are from specific house builders, but that's not important. These are, as far as I'm aware, these are sort of generic, and what they're talking about is handy cupboard space, 10-year warranty mark. There's no mention of the heating solution. There's no mention of photovoltaics. No mention of MVHR. And the image on the right, how is that heated? Is there any generation on the carbon, on PV, on just energy? It is the world out there is not yet really kind of living up to what it probably should be. When you do an analysis of the top 10, and this is based on what I found online, these are the top 10 house builders. Barratt's at the top there, which is great to see. And this is based on turnover. And when you look at the number of homes being produced every year, it is phenomenal. And then when you drill down into these companies, it is interesting that the emphasis from these companies is on aesthetic, on delivery, on creating homes, and carbon is low on the agenda, and I think it probably should be higher on the agenda. What I couldn't find was a top 10 house builders based on how much carbon they have, and how do so the question is, how do we develop a market so we can assess house builders based on carbon, and that will help understand who is doing it right, what homes are doing good. When you go on holiday, when you go to a restaurant, there's a TripAdvisor. They can tell you what's good, what's not good, and it's based on real life sort of experiences. I think it'd be quite nice to have a home builders, a button on the TripAdvisor website, so people who are buying homes can understand. That slide for Cambridge, there's an awful lot of houses being built in the area, and actually it is difficult, I think, for consumers to understand which homes are doing what and for them, and that becomes that would help alleviate some of those I think questions. There are developments out there. We were not involved in this project. This is in Leeds, and this is I've actually been to have a look at an early phase on this building, and I think this is quite interesting that it is sort of there are developments out there which are focusing on carbon, which is one of the kind of the whole topic of today. And the extract there on the right hand side, this is from their website. They're talking about zero carbon design. They are talking about how it's insulated. They're talking about the insulation type. So there is people buying homes and understanding these, and I think this is I think, a direction house builders will be going in. I think it seems to be probably slower than we possibly thought it would be. And I understand there are challenges on that, but I think this should be the direction we're sort of heading. And that previous slide talks about net zero, and I think there's I think it's probably worth, for within this sort of the range of sort of talkers today, just to perhaps just touch a little bit more on what is net zero, particularly from an architect's perspective. And if we're going to deliver you buildings for net zero, what does that kind of mean, and how does that kind of manifest itself? It boils down into sort of two camps. The easy one really is the operational energy. So it says that when you are living in your home, you are operating on a day-to-day basis with zero carbon. So I'll touch on that in a minute. And then the first bit is coming on there and talking about you are constructing, you're building these homes for zero carbon. And actually that's not quite true. So the construction bit isn't zero carbon, but the operational bit is the easy bit. So you're looking at low carbon, you're looking at generating energy, so that's going to bring your carbon footprint down in operation. You're looking at insulating, so you don't need to use as much energy, and you're looking at electrifying the energy source, so you're coming from a low carbon or zero carbon source. I would say a lot of these slides I've cribbed, I've found and collected over a period of time. So these are slides which are out there, and I will give you a sort of a pointer perhaps at the end of this sort of presentation. So operational carbon, getting that down to zero carbon, I think is relatively straightforward. It is being done, and it is being kind of rolled out. I think the hard bit, first of all, to actually understand first of all, and then actually to do is the embedded carbon in the construction. And this is looking at how you integrate carbon, so how you mitigate or reduce the amount of carbon all the way from the raw materials. So you're looking at what materials you're using, where's it coming from, and how much carbon footprint that has, all the way through to manufacturing window units, roof tiles, and how you're getting it to site, and then how you're building it. And then once you've built it, it's a whole life carbon. It also picks up on how you look after it. So if you have materials which need to be refurbished or replaced on a regular basis, that's obviously going to incur a higher level of carbon, rather than some products which are going to take very little repair and maintenance. And then the final bit, which kind of concludes all of this, is what do you do at the end of the cycle? And I mean, that's the sort of the whole understanding the analysis. And I think this is the bit which is harder. It's certainly harder for an architect, and I think it's harder for the industry to sort of come to terms with. There are movements in there, and it is quite interesting. For the whole life carbon, Sadiq Khan, Mayor of London, the GLA, they have targets. So if you're doing certain developments in the Greater London area, you have to meet certain whole life carbon targets, and this is set by them, and this is something you have to quantify, and you have to come back to them. And one of those, this is an example of what you get a kilogram of CO2 per meter squared, and they're going to move this target. This is a benchmark for now, and that benchmark will keep moving. And what it's doing is it's easy steps. So to achieve this it's not completely easy, but actually it's getting sort of easier, and it will get harder as that target comes down. And as an architect, as the design team, as engineers, we need to demonstrate that our buildings are working and can be designed to meet those targets. So the GLA is one element. There's a document by Letty. So if you're not aware of Letty, I would suggest that it's a document you download. It is really important, and within that, they've got data and targets for you to sort of pick and choose. And these are what you should be working to. So this talks about form factor. It talks about renewables. The operational bit I've talked about, but if you go through the heating, demand, and then onto the embedded carbon, they set in targets, which 500 kilograms of carbon per meter squared of your footprint of your area. And how do you then demonstrate that you've actually achieved that is the challenge. And as an architect, that's not easy. I'm going to move on forward. What you do need, you need some software, and we've had to upgrade ourselves, and we've actually purchased the product we've actually purchased at the top here. It's One-Click LCA, and how that works is you calculate the mass of each material. So we work in BIM, and we then break down our BIM model into a schedule of individual materials. That is exactly that's the shopping list a builder would purchase for your house, and we have to schedule that out up front and give us a quantity to that, and then manually plug that into this software and select products. The big impact for the industry and from ourselves, I mean, that's not an easy task in itself, but the big challenge is that at an early stage in our design process, we're making assessment on where that material is coming from. And that doesn't really allow for a huge amount of flexibility down the line, that you change it to a cheaper product, which comes from further afield and with a smaller carbon footprint, because that's going to skew your entire data and your figures you need to work to. And the data which comes out, it's a bit small, but that's fine. It's just a principle. You know, that software gives you charts, it gives you targets, it gives you an understanding of where your carbon is and the big pie charts and the big areas. And that's important, I think, to the industry. So you can then start challenging. You can understand, it's all about data. You can understand where the carbon is on this building. And there's no point, you know, tackling the small pies, because actually it's the big pies you need to sort of tackle. And understanding that is really important. I am running close to time. I've put this slide in. We have talked about the elephant in the room. It isn't being discussed. It is interesting that, you know, there are, I think, you know, 25 million dwellings in England. It doesn't include Wales, Scotland, Northern Ireland. How are we going to do that? The embedded carbon, the construction, low carbon net zero is achievable. It is being done now. It takes money. It takes time from the design team. It takes you know, it takes an extended program, because we need to sort of factor that in, and it changes and takes a mindset. How we deal with this, it's perhaps for a different slide. It is going to be very difficult. My final slide, you'll be probably pleased now, is kind of, I suppose, kind of three things. So what can we do? I think it's top down, bottom up. It is, you know, I think it would be really good that people are, you know, going in. You know, people are buying electric cars, and they're probably asking more pertinent questions on their cars than they will on their houses, and going in. And I think that will change. So I think them coming in and asking questions about how their building is being heated, and where the energy is coming from, and how they're doing it, and how efficient that building is, would be great. Top down, we need more legislation. You know, Future Homes is coming in. I'd like to see that accelerated. I think it will, you know, shift the marketplace. Calculating carbon data, I think, is really important, and it gives everybody an understanding of where we are. And I think at the moment that isn't completely clear. Communication, you know, changing that agenda, and I've mentioned the retrofit. Two final things. There's 3 websites there. I'm sure there are others. They're a very good point if you want to write some more data on there. And then finally, the image on the right there. Again, this is it's not a project we've been involved in, but we are aware of. There are developments out there which are zero embedded carbon and net zero energy in use, which are the 2 things. And I think it's really important that, you know, a lot of developments are just working on one of those. I think actually, you know, getting both those is really important. Right. Thank you very much.
Thank you, Robin. That was an amazing amount. I started off being really depressed by those schemes that aren't doing anything. I think by the end we were seeing ways that things can happen, and I wonder how much impact the sort of dreadful circumstances that we're living through at the moment are going to have in terms of people just having to look at what their fuel costs are, and really, if they have any choice at all, wanting to live somewhere where those costs are going to be lower. That's something for our discussion at the end. I will reiterate again, do please send your questions in. And now we're going on to our next speaker. And I know that Martin, in his presentation, talked about things going from the neighbourhood and city scale down to the component scale. And that's certainly not an either or. We have to get things right at every scale. And now we are going to come down to talk at the more direct component scale. And that will come from our next speaker, who is Kieran McAlliskey, who is National Specification Manager for Ireland at Keystone Lintels. Kieran.
Thank you. Good morning, everyone, and thanks for dialing in, obviously, for today's seminar. As I say, I've been with the company for the past 11 years as National Specification Manager, and I'm just one small cog in the Keystone Lintels machine, with the company itself leading the way in lintel manufacture and design for over 30 years across the UK and Ireland. very hard acts to follow this morning, but what I will be doing in this short session is focusing on net zero from the perspective of a construction product manufacturer and how we approach legislative change in the building regulations through innovation and design. And through this approach, we can help contribute towards the government's targets of net zero. The agenda for today begins by looking at this from a lintel perspective, and where lintels are touched on most in Part L building regulations, especially around the area of thermal bridging. We then look at how Keystone has reacted to this with its own unique lintel to combat thermal bridging. I then touch on the cost benefit of this with the help of a case study to highlight where savings can be made. And again, as previously mentioned by some of the other speakers, it's something that's never more important than in the current climate today. And we wrap up finally on how Keystone internally have adapted to create its own sustainable framework. So let's get started. So every building produces CO2 as it uses up energy to heat, light, and ventilate the space within it. Heat's then lost through the walls, the floors, and the roof of the building, and that's sometimes referred to as the fabric of the building. A thermal bridge or a cold bridge is an area of building construction which has a significantly higher heat transfer than the surrounding materials, and this is typically where there's either a break in the insulation, less insulation, or the insulation is penetrated by an element with higher thermal conductivity. Thermal bridging, big concern in the building industry and a significant factor in heat loss in the building fabric. And recent research undertaken by the BRE, the Building Research Establishment, has shown that thermal bridging can be responsible for up to 30% of a dwelling's heat loss. So by reducing heat flow through the building's thermal envelope, we can reduce energy consumption of the building and lower the amount of CO2 it emits, which is a key focus of Part L. And Part L is very much seen as one of the first stepping stones in the government's pursuit of net zero due to the significant energy usage of households. In the UK today, the average household emits 2.7 tonnes of CO2 from heating their home. And that's not over the course of a lifetime, that's in a single year. And that's the equivalent of charging up about 300,000 smartphones every year. Part L 2022 calls for the reduction of carbon emissions in new homes by 31%. And that's getting us ready for that future home standard from 2025 onwards. The common misconception about Part L is that the document is for the process of constructing the dwellings and not the day-to-day running of the household. But of course, this is not the case. And dwellings are being designed as per Part L to produce 31% less carbon emissions. And the document looks at a number of measurements, including fabric energy efficiency, energy rate, and emissions. And the introduction of the energy rate identifies somewhat haphazard approach that has been taken in the past, where builders or assessors alike have looked to offset the use of inefficient materials by hitting targets with renewables such as solar panels. And that sort of upends the energy hierarchy to a certain extent. So it's sensible to reduce energy demand initially before replacing this with renewables. And due to a lack of accuracy that had previously been seen, Part L has introduced a number of detailed accuracy measures. So some of these measures are minor tweaks to previous requirements, and others will see a relatively significant change in the way construction is run and how accuracy is assessed. One standard is that photography of key junctions at certain construction stages will be required for all new dwellings. And this will need to have the correct technology activated with reports provided to building control and the building owner. Energy assessors alongside developers will need to ensure specification has been followed to ensure that the dwellings are built as they are designed. And that encourages product specification that helps reduce thermal bridging and doing away with changing products after design. And if done so, a revised specification should be put through SAP to allow for this. So as a lintel manufacturer, well, how do we approach this? Well, the primary function of a steel lintel is structural. It's installed to support the load above. However, in doing so, it breaks the insulation layer in the cavity of the wall. And the steel is a highly conductive material. The lintel provides a clear path for heat to escape. So for this reason, when it comes to thermal bridging within a typical house, steel lintels can contribute significantly to allowing heat to escape. And this is demonstrated in the image shown. You can see the heat transfer is higher above those openings. And thermal bridging comes in two forms. You've got that repeating and non-repeating thermal bridges. Repeating follows a pattern over an entire area of a building's thermal envelope, for example, in steel wall ties for masonry cavity wall construction. Non-repeating thermal bridges are the exact opposite. These thermal bridges occur sort of periodically or more sporadically, and are found where there's a break in the continuity of the building's thermal envelope, such as reveals around windows, loft hatches, and other openings. How this is calculated has recently changed. So previously, SAP calculations allowed energy assessors to use a generic value. However, these generic values are no longer accepted within the assessment, and this allows a return of a much more accurate result and incentivizes a different approach, a fabric first approach, if you will, which is why it's more important than ever to carefully consider the materials that we are installing when designing and building houses to eliminate those thermal bridges. With a clear goal of Part L being the reduction of primary energy use, ensuring heat is retained within dwellings is paramount importance. As such, reducing thermal bridging is a critical component to creating a thermally efficient home. Obviously, as Martin had mentioned earlier, in regarding the summer at the moment, his house is cool in summer, so we always have to take that into account. Treating Part L as a stepping stone to the future home standard means taking a fabric first approach, which puts us all on the front foot when it comes to designing dwellings to reduce carbon by that 75 to 80%. By having a fabric first approach, means you're designing to maximize the performance of the components and materials that are making up that building fabric, rather than relying on post-construction additions such as energy-saving technology. And not taking a fabric first approach can mean costly redesign to meet the future home standard requirements, which is coming fast down the track. On the slide, we have a few examples of materials which can be considered to pass the new requirements of Part L. And of the few examples shown, perhaps lintels are the only true fabric elements which are not easily changed in future, which is why we stress looking at solutions before we get to bolt-ons or retrofitting, and why we would advocate the use of high-therm lintels. And specifiers are actively looking for the most cost-effective and efficient way of meeting the ever-tightening building regs. Alex Brooks from AES Sustainability Consultants described it as essentially replacing a lintel with another lintel, which is attractive to house builders as it meets the targets required in an efficient way and provides effectively an easy win. And on screen you can see the high-therm lintel. They work in the exact same way as standard steel, with one major difference. Second material has been introduced along the upstand of the lintel, and that's known as a polymer isolator, which isolates the inner and outer leaf of steel and helps create a powerful thermal break. Working alongside that is a CPC-free insulation, and that ensures that there's compliance with Part L in having that continuity of insulation throughout the dwelling. And finally, on screen, as you can see, you've got that warm inner leaf of galvanized steel highlighted in red, offset by that cold outer flange represented in blue, indicating how that heat is retained within the dwelling. The lintel also has the flexibility of those coastal or corrosive areas, with the ability to replace the galvanized outer flange with stainless steel. So throw that all into the mix. That allows high-therm lintels to be 5 times more thermally efficient than standard steel lintels. So as standards and regulations tighten, the impact of switching lintels alone can be significant, with Keystone investing heavily in research and development to engineer the high-therm lintel for the industry and the end user. So to design efficiently for Part L, it's important that energy assessors use independently calculated SI values or manufacturer calculated SI values, as long as they're done by the correct people, trained people, using the correct software. Our experts in-house, they use Fisabel Trisco thermal analysis software to calculate SI values and then advise clients on specification for compliance with the required building regs. The table on the slide shows the standard SI value at 0.23 watts per meter Kelvin, with a direct comparison to the high-therm lintel, which achieves a SI value of 0.03 to 0.06 watts per meter Kelvin. So this shows a much superior rating for the high-therm product, which is around 5 times more effective. Increased regulations do lead to increased building costs. So the current cost of living crisis and the global supply chain is making all sectors think differently and creating a step change from consumers in how to heat their homes more efficiently. And on screen are a number of methods that are often considered. And based on use on the average 3-bed home with a 75 metre square floor area, Hytherm offers a cost-effective solution to lowering those carbon emissions within SAP and helps give significant savings compared to other alternatives out there, such as mechanical ventilation or a wastewater heat recovery system. On screen, you can see a project we worked on at Britannia Gate. The breakdown in this slide shows a comparison between the two typical routes developers have been taking. We often see widening of cavities and increasing insulation within walls and floors. However, as you can see, doing this requires a significant cost uplift. So whilst we accept there's a cost uplift in specifying Hytherm, from our research, this was significantly cheaper than increasing the specification on the insulation. And as such, we were able to deliver a nearly just under £12,000 cost saving for the Britannia Gate project. Just before we wrap up, I wanted to mention briefly what Keystone Lintels and the wider Keystone Group is doing in its own commitments to net zero and sustainability. And Keystone's looking to lead the way with innovation in construction and sustainable performance. And in order to do that, we want to build decarbonisation into all business operations and become one of the first UK construction product manufacturers to achieve net zero for our sector. To do so, we want to adhere closely to new policy or be ahead of the curve in achieving net zero 2050. And that means using 100% renewable energy, securing a fully sustainable materials pipeline, manage 100% of our waste, and use a 100% sustainable fleet operation. And to date, we've implemented considerable amounts of this, but we're still a journey to go for us and for many companies as we progress through the decade. Just finally, from our foundation, we've always kept close to or sought the accreditation on Keystone products through a number of organisations on screen. So this allows us to make high quality products that we've been tested to the highest standards with the BBA, Eurofins, and the Building Research Establishment being notable mentions. And this allows us to conform or outdo the standards of the day in order to innovate and commit to our own sustainability targets and the building regulations as they continue to evolve. So I'd just like to thank you for listening to this short presentation, but hope it's given some insight into how Keystone Lintels have approached the changes to Part L and by extension, its drive towards net zero, both internally and externally, with use of the Hytherm lintel and its low SI value, which can help reduce thermal bridging and improving the energy efficiency where it is installed within the builds. So thank you very much.
Thank you very much indeed. I think there were really two takeouts from that. One was to see what a large impact a relatively small element of a building can have in terms of its thermal performance, which I think we know but needed reminding of. And the other was that cost of the improvements against the price of the interventions. And of course, again, it probably shouldn't be either or, it should be and. We should be doing as much as possible, but it's really valuable to see that and to see where those lintels fell on that chart. Now, we've been talking about lintels as one element, and in a minute, we're going to talk about another element. We're going to talk about windows, and in particular roof windows. Before we do, I know we've got some really interesting questions coming in already. Please do keep sending your questions in because after this presentation, we will be having our group discussion. But for now, I'm just moving you on to Colin Wells, who is Head of Technical at Keylight.
Okay, thank you, Ruth. Hopefully everyone can hear me okay. So thanks again, everyone, for joining us today. It's a real privilege to represent Keylight here. My name is Colin Wells. I've been in Keylight for just over 16 years now. And during this time, I've fulfilled many different roles. And by going through these roles, it's allowed me to obtain a lot of experience throughout the construction industry. Currently, as Head of Technical, I I head up the technical team and the R&D team, and also pull these teams together to support our guys on site, as in the sales team, but also with architects and the installers as well. And yeah, fun fact, I'm a bit of an American country music fan. Sorry about that, but can't all be perfect. To prepare for today's webinar, I really just asked myself, how can roof windows play their part and help deliver zero housing? Ben, you mentioned about asking your suppliers to adapt and try to come up with ideas to help you as a builder, or to provide zero housing. And the answers that I can come up with from a roof window side of things is heat retention, air tightness, and natural ventilation. Firstly, I want to look at heat retention and air tightness. The most recent version of Part L states that gaps in insulation can cause significant heat loss and create risk of condensation. And what does that mean for roof windows? When an architect or specifier details a roof window on their sectional drawings, this is what they'd like to see. So on this section in front of you, you can see it's a section through the roof. With the roof window on the left, you can see the glass on the left-hand side, the frame and the sash. And then there's a highlighted part with insulation in it. And most or all architects and specifiers, when they are detailing up their buildings, this piece of insulation will be added into the drawings and specified on the specification sheets and the bill of quantities and everything else. The reason for this is that when installers are installing a roof window, sorry, just back a slide, every roof window manufacturer recommends that the opening for a roof window is 40 to 50 mil bigger than the actual window itself, and that's to allow for ease of installation and allow for the roof window to be square in the roof. But unfortunately, this doesn't always happen, and there's a huge percentage of roof windows being installed without the thermal collar. And if any of you want to try and take a guess, I know you can't talk to me, but even in your own heads, think what that number would be. It's pretty substantial. Our recent market research suggests that 97% of roof windows are installed without a thermal collar, which means you have a greater chance of heat loss in this area. This detail doesn't match what the architect or roof window manufacturer is actually specifying, but unfortunately, this is the reality on site. With no thermal collars installed, we call this the performance gap. So you can see again on this detail that the gap has been left clear and the heat loss is coming out through the frame. So this is the gap, and it's the grey area of roof window installation. Who's responsible for it? Is it the joiner or the roofer or the insulator? Nobody really knows the answer. So off the back of this, I want to take a look at some of the reasons why the thermal collar is not being installed. It's an additional product at an extra cost per roof window, approximately £30 per roof window to purchase this additional thermal collar. It's an additional component, so it's not in the window box as standard. It's something else you have to buy. A lot of people just when roof windows are being purchased, it's the window and the flashing, and they think that's it, off we go. Again, it's specified, the manufacturers recommend it, but unfortunately, the merchants wouldn't hold it in stock, so it has to be pre-ordered in and may have a longer lead time on it. So after identifying these issues, Keylight has taken ownership of this, and through extensive research and development, we have eliminated the installation weakness and filled the gap with our patented expanding thermal collar. This is assurance that what is specified on the drawings is a reality on site. As you can see, this unique feature is integrated into the frame of every single roof window. Doesn't matter what size or what specification. The roof window is installed and the tabs are pulled away and the thermal collar will expand to fill the gap. The thermal collar itself, once it expands, it improves the air tightness around the window, as well as improves the psi values for SAP and the overall performance of the actual roof opening. For example, if you had a typical roof window has a U value of 1.3, if you install it into a roof opening and don't insulate the gap, that roof opening U value could be as low as 1.7, where if it's fully insulated with a thermal collar, the roof opening will be 1.3 in line with the roof window itself. So I want to try just to explain how this works. So again, I've got sections here through a roof. On the left hand side, you'll see on the detail on the left, the one with the gap, you'll see the roof window with the glass, the frame, and then the section across the roof. And you can see that the gap is uninsulated. And on the right hand side, you can see the same section, only the insulated or insulation is in the gap. If it's 0 degrees outside in the roof, it means it's 0 degrees in the gap. So what occurs here is heat loss, and this occurs from the inside of the building to the outside. I'll just zoom in on this detail slightly. And you can see the surface temperature of the glass is at 17 degrees. And inside of the room is at 20 degrees. But because it's only 35 millimeters of timber really between the inside of the room and the outside of the room, you can see that the surface temperature of the frame drops below the dew point. And unfortunately, this will cause condensation and mold growth. By not addressing this gap, there's a higher chance of condensation and mold growth going together on the frames of the roof windows. By activating the thermal collar to fill the gap, this helps prevent the heat flow through the frame and improves this, and increases the surface temperature of the frame and avoids or keeps the surface temperature up above the dew point. On the diagram on the right hand side, we can see there is no temperature gauges added on the glass and on the frame. So that room being 20 degrees, the same as the diagram on the left, we can clearly see that the glass stays at 17 because the room is at 20 and the glazing unit is the most efficient part of this window. But with the thermal collar being added, we also keep the frame surface temperature at 17 degrees, which keeps it above the dew point. Keylight approached the BRE, or the Building Research Establishment, to demonstrate the impact that Keylight roof windows thermal collar has on the risk of internal surface condensation on the frame. The BRE conducted tests and produced a condensation risk analysis report which stated that the thermal collar would be necessary to prevent condensation and mold growth, confirming our own internal reports and findings. Okay, so that's heat retention and air tightness covered. Just showing you that this collar, it has been for years available on the market, but it is very, very rarely used. And it's something now that we have added onto our product at the same cost. It's not additional now, just to try and take ownership of the actual issue and try and eliminate it. The final point then is ventilation. Due to the houses being built now and they're becoming more and more airtight, and also the latest version of document F has increased the background ventilation requirements in some cases from 5,000 millimeters squared up to 8,000 millimeters squared. Our houses nowadays don't have gaps in under the front door or leaking air through the ceiling or the chimneys and everything like that. So background ventilation is becoming more and more important. With Keylight's top opening handle, we can support these needs and in some cases remove the requirement for additional vents. So the windows have a top opening vent that can be operated to open and close the roof window itself, but also on the initial first click will provide background ventilation into rooms and help with air recycling within the building. It's important to note that the windows with the top handle, when they're initially clicked open, they will provide background ventilation, but also remain fully locked and secure. In Part F and on the NHBC Standards 2022, they have stated that a window being opened in the night latch position can't be accepted because of undue drafts or unwanted drafts, but also security risk. So, final thought from Keylight. Heat retention is standard on every Keylight window. Air tightness is standard on every Keylight window. And secure background ventilation as standard on every Keylight window. And again, I'm open to take any questions afterwards, and I look forward to answering them. Thank you.
Thank you very much indeed. I think that was fascinating, mostly to see not only the level of problems with installation of standard roof lights, but also that you've come up with a solution which is not really even technically new. It's just a way, and a very important way, of getting round what you have seen as a general malpractice. Now, we fortunately have now got some time for questions and to discuss all those things that came in. And I'm not quite sure, are we going to see our panel all together? Maybe not. But I thought, in the light of that last presentation, it was really interesting to pick up a question where someone's asked, how does the panel propose the facilitation of education and support for smaller jobbing builders on how the new regulations affect them and how they can comply cost effectively? Yes, we're all here. I'm going to go to Martin first, because I think you touched on this as skills. Obviously, the jobbing builder is not really involved, we hope, on new build, but I think there's a larger issue around knowledge, education, and training.
That's a really good question, Ruth. And I think it's an incredibly valid one as well, isn't it? Because it's not just the jobbing builder. I think it's the industry at whole, isn't it? How do we take our existing skills and knowledge that we have, and how do we ensure that we create the bridge from the way we construct today to the way we might need to construct in the future? And it is about that transition, isn't it, in terms of how do we make sure that as we develop new ideas and technologies, it isn't just about the technology, it is about the skills that we require to make it work on site. And I think that is a really big challenge. And I think part of that comes through ensuring that the sector, the built environment sector, work with educational establishments. So how do we make sure that as people are becoming professionals or becoming people who are going to be on site to build some of these buildings or within a factory environment, that they know the importance of some of those techniques? How we make sure that as we move different technologies into site environments, that we actually take people with us. So can we use, some of the existing skills, but maybe the product is slightly different. So when it comes to bricklaying, maybe traditional bricklaying is a thing of the past, but actually the skills you need, we can actually upskill and retrain people in the same way that I think Rob and Ben talked about in their presentations. it's not an easy one to answer, but I think it's about making sure that we are accounting for it. We work with the educational establishments, we work with the industry. And then I think the last measure that we may want to think about is when we look at a building and how it's approved, we also look at the people who are building that building, and do they have the skills to deliver it in a way that meets the requirements. And I remember a while ago, I was doing a little bit of a project about how can you link the final sign off of a building with the skills that the individuals had. So can you actually say that this building was designed in a particular way, the right professionals were used in terms of installation, the right people were used in the way the building was then commissioned and operated. And if things are not working well in that final operation phase, can you then go back, find out which of those individuals were involved in the process and support them with upskilling again? So it's a continuous cycle of learning, isn't it? It's not just a once off, it's kind of a process of making sure that we keep on training and retraining people to make sure we get the best quality possible.
Yeah, I'm going to come to Ben now, because I know you touched on this in terms of heat pumps and heat pump installation. That was your presentation, wasn't it?
Yeah,
yes. Sorry, I remember it, and I'm thinking that was you. But obviously there is a wider thing, isn't there, in terms of everything we're looking for. And I know that somebody's also asked a quite specific question about photographing junctions and things, and how you actually do it. And of course, all those details are just as important as that really big picture of policy. So I don't know if you just want to talk about some of the challenges, Ben.
Yeah, so I suppose photographic evidence, it's a new process that's been implemented around our sites. So it's really aimed at, we know there's a performance gap, we need to close that. And it's going to involve taking photographs of key junctions. So off the top of my head, I think there's about 12 key junctions within the building. So our site teams will be taking photographs of those junctions. They'll be sent to the either the technical manager or coordinator in the region, who will check that it's been built correctly, the right products are in there. It will then be sent to our energy assessors, who will sign it off from an energy point of view and a thermal efficiency point of view. And then those photos get sent to NHBC, and which ultimately end up with the homeowner. So it's another step that's really aimed at driving out, incorrect product substitution, which we know, we don't want it to happen, but it does happen. And also, driving quality and reducing the performance gap. So that's what that one was about, I think.
And Kieran and Colin. Sorry?
Was there a second part to the question? Sorry.
That'll do for the moment, I think. I'm going to go to Kieran or Colin. I'll let you choose which of you, because obviously you're designing products, you're supplying them to the market, and your products have to be installed, and they have to be installed by people who know what they're doing, don't they? I mean, how do you address this, and how much more of a challenge is this becoming as the way we build needs to be better and better, and possibly there are new ways of doing things as well? Don't know which of you two would like to pick it up.
Well, I suppose it comes back to the question that Martin was asked at the beginning as well, I suppose, in terms of education and training and things like that. And I know between, not to speak for Colin, but with Keylight and with Keystone as well, we have training academies, and we support installers and different industry bodies in order to educate people on the products that we're supplying out to the market, because there's no point in creating a brand new product on the market and then everyone's sort of just looking at it going, what do I do? We have to provide that information and get that flow going, that people understand the importance of implementing something like that. And we're even going down to the lengths of I suppose taking it from like students, and at the minute we're trying to roll out a program towards sort of apprenticeships coming through and student bodies in order to educate them on products, and by extension the building regulations as well. So you've got fresh people coming through, but not to be ageist or anything like that, but there's probably an element of trying to getting the people have been around a long time to adjust their way of thinking, and people can become set in their ways, I suppose, too.
Thank you very much. I think I'm going to move on to some broader questions now, which are actually, we've had two questions in from John Mellor. One of them saying, is Part L and 31% reduction in carbon going far enough? Should we ensure that future home standards are met earlier than 2025? And I think this might be an interesting thing to pick up in a moment, possibly with Ben. But the other one is, does the panel believe there will be an increased impetus to build a larger percentage of housing in timber frame from the major house builders due to the sustainable nature of timber? And I'm not going to go to house builders, I'm going to go to Robin and see what your view on this is. And I know that obviously, I mean, timber has enormous advantages. We do also have issues that seem to be raised by insurers around, well, partly around fire and also I think around water ingress.
I think it's a really interesting question. It's one we are grappling with ourselves on projects, and I think timber has to be a construction solution for a lot of projects. And I think at the moment the industry is finding that there are some challenges with that. And I think it is, you know, we're finding an interesting conversation with light gauge steel. That seems to be a sort of a prevalent sort of conversation which keeps coming up, and that is, you know, it's obviously got a slightly different sort of carbon footprint than timber. I think timber is getting there's a degree of challenges with the supply of timber and the companies who can supply certain volumes of development. And that was certainly the conversation we had when you were having to sort of explore at concept stage a timber solution. You know, who's going to supply it? How available is that? How competitive is that market? And I think when you've got an industry and you're going out to develop contractors who are going to be developing this and constructing it, how much appetite do they have to take on board that supply chain and that risk with that supply chain? From an architect, I think I'd be very happy to build in timber, and we have done that on timber. I think it's the question is scalability. I mean, you know, from Ben's perspective, he's obviously producing a huge volume of you know, and if all of a sudden, I think if you suddenly were going to timber for every single one of your house development, if that was feasible, I think the market probably couldn't handle it. I don't think there's enough timber suppliers. So there's a scalable question there. But in answer to the simple question, sustainability, it locks carbon into the building. I mean, it's a simple tool to do, you know, in that analysis, and it should be done. There are ways to overcome the fire, and there are ways to overcome you know, the issues. It does take, you know, it takes drawings, it takes consideration, it takes a design team, really. Yeah. Ben, do you want to mention? I mean, from your perspective, I mean, is there challenges? Do you have a percentage of timber frame in your portfolio?
Yeah, we do. We've gradually been increasing it over the last couple of years. I think we're up to about 25% now. We're looking to grow that to 30%. And as you just said, look, we can't do it all in one go. We're gradually increasing it due to, you know, the scale we're at. But also we do need a mix of construction around the country. The nature of our building, we build all over the country. Some areas suit masonry better. But what we are doing, where we're still using masonry, is we are challenging our supply chain, you know, our brick suppliers. How can they reduce the embodied carbon within that? You know, we're looking at reducing brick sizes to make them sort of thinner and reduce that. So we're actually challenging masonry to reduce the embodied carbon whilst increasing timber frame as well.
There's a perception that timber frame, you know, structures and frame structures are easier to become airtight, and actually, you know, and therefore when you're talking about trying to reduce heat loss, and we're trying to, you know, and reduce energy, you know, consumption of the buildings, you know, the airtightness is a really important element of that, and timber frame can help in that. You know, you can still do that with traditional. It just becomes a bit more reliant on the skill force and the workmanship.
I'm going to come on with a sort of another question for you, Ben, which is, I mean, it's partly someone saying, should we be pushing even further on standards than we are? You know, should we try to do future home standards now? And another question that came in, which I think is pertinent, is somebody looked at your sort of current design, which you showed, and said, why are you going with double glazed windows? Why are you not going with triple glazing? And I noted, of course, that when you talked about increasing the level of insulation in the building, you're increasing the building footprint, which eventually is either making the garden smaller or increasing the land price. And I just wonder if there's a way of talking about how you trade off your aspirations against costs and how much you can sell homes for.
Okay, that's a good question. I suppose if I split into two, answer the triple glazing side first. So we're currently reviewing triple glazing. Again, going back to the scale we build at, 18,000 homes, moving to 20,000. A few concerns around availability. Can they supply all of our houses? There's a few areas around manual handling. So from a triple glazing point of view, much heavier. You have to do the glazing separately to the frame. So a few things we're working through at the moment around that. So it's not the same, we're not going to do it. It's a case of we have to trial it, adapt the business over time and decide whether we change it. I suppose the second part about is part L is the next, I think the question was around, is 31% enough? I would say, look, 31% is the biggest change we've seen in a long time, certainly since my time in the industry. I think we've got to be realistic. We've got to give a bit, in an ideal world, we'd all be zero carbon tomorrow and we'll just do it. But the reality is we need to upskill our installers. We need to gear up the supply chain. We need more UK products being manufactured in the UK, and we have to adapt it over a period of time. So yeah, I don't know what Robin or any others have any thoughts around that as well.
I think there's challenges. I think I'm with you. In a very sort of simple answer to the question, should 2050 future homes be available now? Yeah, and I think if I've got one concern is that when people look ahead and say it's future home standards in 2025, there will be some house builders out there, some clients who will not do anything until the 27th of December 2024. And I think that's the concern, is that as soon as you put a marker in there, you're going to have a lot of people still using it and saying, why should I step up until legislation tells me to step up? And I think it isn't binary. It isn't just a switch you can switch on, because I do take on board the fact that the scalability and I don't think the industry is quite there. But I think at the same time, we do need to move the conversation on, because otherwise we will just be working. There'll be a percentage of this industry which will work right up until the last minute, and then only go because legislation tells them to. And I think the problem is that legislation is only part of, and keep in mind, legislation is only one part of the tool. If people were saying, I'm not buying that house, I mean, if I was buying a house in the end of 2024 and it's not future home standard, I'd be kicking myself very quickly, because I know that if I buy the house in 6 months' time, I've got cheaper bills, I've got a better efficient building. So the message from the market and from everybody should be trying to change that conversation.
And how do we? I mean, I think that's really interesting, and I think it is another question that came in around marketing and advertising and making people understand what they're getting. But for so many people, whether they are buying a house at the limit of what they can afford or looking to rent somewhere at the limit of what they can afford for rent, their choices are often determined by what they can get and what they're being offered, rather than actually being in a powerful position. Now, of course, everyone's had an awful wake-up call, because everyone's enormously worried at the moment about their fuel bills, and I don't think whatever happens, that worry will go away. So I'm just going to put it quickly to each of you. We've got people from Keystone and from Keylight, both of whom are offering products which you want to think that the consumer would say, yes, I want decent, proper working products in my house so it will perform. We've got Barratt, who want to build better homes, provided you can actually find people with the skills to install the heat pumps or whatever. We've got Robin, who cares hugely about the design of homes and making them better, and we've got Martin, who's been pushing this whole thing forward and kind of acting on the legislative side. How do we actually get the public to understand enough to put pressure on the people who are dragging their heels? It's my last question, and I'm going to ask it very quickly of each of you. I'll start with Martin, and we'll have the short answer, I think.
Okay, short answer. Education awareness, training demand, options and value. So you need to educate people about why this is important, and that's about the sector as well as the consumer. You need to create consumer demand to ask for the right thing. You need to have options in the market so you can buy the right thing, and you need to demonstrate that what is changing brings value to the consumer and value to the industry.
Robin, you've shown the wrong information. You've talked about the people who drag their heels. How do you get the market to actually pressurize them?
I'm going back with education. I think if you're buying a house and then you know that in 5 years' time you're going to have a large outlay because gas won't be available in your region or you need to change it, it is a false economy. I think so. Yeah, just educating that on the horizon is going to be a capital a capital investment needed from you. You just bought a house for £300,000, and if you're going to have to invest again in 5 years' time, you need to understand that. And therefore, I think you need to explain to people that it is a false economy to some degree at this point, buying something and not expecting to spend money in the future. I think people buy houses thinking they don't have to spend anything for 10, 20 years, and that will not be the case going forward. Education.
Colin, if someone's doing, I don't know, a roof conversion, they're going to put a roof light in, how on earth do you get the consumer to understand that they actually need to make sure that they've actually got some insulation around it, either because their builder's done the right thing, or better for you, they're actually buying your product?
Yeah, it's not that simple, but one of the things the other guys have touched on is it's education, right? But Ben also touched on it, and I wanted just to mention it, to go back if we can a second, that even when we're bringing in new research and development engineers now, they're all being taught about sustainability and everything green, and like we have two new guys in this year, and we're looking about recyclability and everything, and they've been taught it. They've been taught it, and it's something that we never would have heard about 15 years ago or considered. They weren't taught it at university, but now their degrees are actually being, as product design, part of their degree is about sustainability, which is fantastic to see. They're actually coming in and teaching us older guys a bit of stuff about recyclability and sustainability, which is brilliant.
Right.
So to go on to how does an end user decide, or how are they aware about a thermal collar on a roof window? Again, education is all we can do, is try and get the message out there, and to the merchants, to the builders. We, as Kieran touched on, we try to carry out installer programs just to educate installers throughout sites to try and help them.
And I'm guessing, Kieran, that's where you're coming from, because frankly, no member of the public ever thinks about the quality of the lintel that's going into their building, do they? Unless they happen to have knowledge. It's not the sexy thing they're going to talk about. But I suppose you've talked already about sort of trying to educate installers, and it's just more of that, isn't it?
Yes, so there's, in fairness, I'm just sort of echoing what some of the other guys have said about education, I suppose. And I suppose the current cost of living crisis, and I'm not saying that's a good thing in any shape or form, but I think it does make people start to reassess and think about their household bills in terms of introducing popular measures. Now, obviously, if the price of the bills dropped away again, people can become careless again, and it has the opposite effect possibly, but it does create a rethink in the brain, I think, for possibly looking at the future home standard. And as Robin had mentioned earlier, about he'd be kicking himself if he hadn't bought a house for the future home standard in 2024. But if he'd known, but it's a case of people just don't think about things like that at the moment. So education, that's it.
Ben, obviously,
sorry, can I just interject? Sorry, do you want to? Sorry,
very
Ben.
quickly.
Yeah.
Over time.
If people have a lot of weight on things like NHBC standards, you know, and actually, you know, when you're buying a house, Ben, I mean, you know, maybe you're touching this, but you know, that gives them a degree of confidence that actually it's got a warranty and it's got a kind of performance. And actually, if NHBC and the warranty providers are there ensuring these things happen, ensuring these products are in there, then that should give them the confidence. So actually, the warranty provider is probably the access to the users, because when you go when they're inquiring about houses, that's one of the things they're looking at.
Ben, are they?
100%.
You're selling all sorts of housing. Yes.
Yeah, NHBC, as Robin's just outlined there, NHBC 10-year warranty. So that's kind of, covers up all of that one nicely for the customer, so they can be confident that it's been built to the relevant standards and been checked out along the different build processes. I suppose just to finish up from me relating to the other questions around, I suppose if we draw some comparisons and be clear that obviously houses built to today's standards, never mind the future home standards, are already way ahead of the typical average sort of existing property in terms of running costs. You know, all of our houses are an EPC and B or above. And it's when we move into the future home standard, they're going to be super insulated and even lower running costs. So customers can be confident, obviously, if they're buying new build, they will be paying less for their bills quite considerably when we're looking at the new price caps as well. But what I think is going to be key, and we've all touched on, is education and for the consumer as well. So when they are moving into a house with a heat pump, it doesn't operate the same. They need to adapt their behaviour. So that is going to be crucial, and we're going to do lots of work around that in terms of home user guides and how we actually engage and communicate with our customers.
Thank you very much. And I am going to draw that to a close. I mean, I found it fascinating. I hope everyone who's been watching has found it fascinating as well. This is the first of 3 webinars that are going to be 4 webinars. I'm sorry, there'll be a further 3 that will be running through this autumn. Thank you for attending. Thank you for your questions. Hope to see you again talking on some of the other key issues. And it just remains for me to say thank you so much to all of our speakers and goodbye. Thank you.
Thank you.
Thank you.
Oh, my eardrums have just burst.